Hello, James Flaten here from the Minnesota Space Grant to talk a little bit about data analysis from a stratospheric balloon flight. So depending on what you flew, you may have video data to analyze, you may have experimental numerical data to analyze, and that data in fact might even be organized for you, in which case what I'm going to present, analyzing things from scratch using Microsoft Excel, might not be that useful. But I think it is valuable to know what Excel can do for you, even if you plan to use other software packages for analysis. Let's talk about videos first. So I just opened up a set of videos that came from a given balloon flight. It turns out this is fairly typical. The camera will make file after file after file. You assume that the files are adjacent in time. Hopefully that's true. And this happens to be a downward looking camera. And so I usually want to look at the data and figure out when the flight started. So apparently this thing was sitting on the ground and the camera was blacked out, literally, until approximately movie number 6. So presumably it was launched sometime during movie number 5. Let me just open up movie number 5 and look for the launch. So this is part of the analysis, is find the timestamps for the important details. I'm going to turn off the audio and just look at this by video. So I'm just forwarding. So here are people holding this payload, and let's find a time when it starts to fly. It's getting ready to fly, it's getting ready. And there it is, it's released. Okay, so right about, okay, so 4:13, in other words, 4 minutes, 13 seconds into this file is when this particular flight started. Okay, that's worth knowing, and the reason is if I want to find out for any later moment in time in a different video, I just have to add up how much time has elapsed. And so here's something else that I might be interested in looking for. Let's find burst. Okay, so this thing was presumably ascending. Movie number 27 shows a rather different view, so I suspect that is post burst and coming down, possibly tumbling. So I'm going to hazard a guess that movie 26 shows burst. Let me just open movie 26 and look. If it's steady, that means it's not yet burst and it will become unsteady. Even at the beginning of movie 26, it's already apparently has burst. So I'm going to go back to movie number 25. This is ascent. It is rotating, but it has not yet burst. So let me see if I can find the moment in this video. Each of these videos is only 4 minutes long, which is surprisingly short. Here we go. I'm up to 4 minutes, 23 seconds, 4 minutes, 27 seconds, 4 minutes, 32 seconds. I'm pretty sure I'm getting close to burst. Here we come. Right there. That little snap was burst. And I know it's burst because now I start to see things flying around. Okay. So at 4 minutes, 39 seconds, into this video, I'll go back to it right there. That was burst. Of course, if you're looking at the balloon, burst is more obvious. But so this is going to be key to video analysis. And for instance, let me go back to the beginning of this particular file. I'll even go back one file before. So here's movie number 24. And at the beginning of movie number 24, there's something in view. Maybe it's something interesting. I could figure out how high I was by just calculating how much time has elapsed since I launched, and then going and looking at an altitude versus time graph and figuring out exactly what was going on at this moment in time. And then I could say, yes, indeed, this shows such and such a river from, 92,000 feet or whatever is the appropriate altitude. Okay, so again, look at the different files, identify the moment in time when specific things happen, like release, like burst, like landing, and then you can use the numerical data to try and figure out how much time has elapsed in flight and what altitude were you at when that data was collected. On the other hand, let's look at some actual numerical data from that same flight. So I'm going to open up a CSV file that was taken by a pterodactyl flight computer that was on that flight. So CSV means comma separated values, which means that Excel is able to read this thing. And the first thing I'm going to do is I'm going to save this as a genuine Excel file. I'll just put it on my desktop. Here we go. Save it. Okay, so now I'm actually looking at a genuine Excel file. And let's see what I have in here. I have the year, the month, the day, the hour, the minute, the second, latitude, longitude, altitude, and then a bunch of sensor values. Okay. The first thing I notice is that the first line here is clearly off. It has the wrong year. It doesn't have any GPS log. So I'm just going to delete that. Get rid of that data. I know that data is bad. The next thing is that it turns out one thing that's missing from this particular record is an actual running time. So I'm going to make one. I'm going to click on this column. I'm going to say insert, insert, insert. So I now have 3 new columns ready to go. And I'm going to label the first one time, capital T in seconds. So capital T is how much time has elapsed in seconds since the beginning of the record. And I will click on that cell and type equals hour times 60 times 60 plus minutes, which happens to be P2 times 60 plus seconds. So apparently this is 42,389 seconds into the day from midnight. And if I took this and just subtracted off 42389 minus 42389, now it's 0. So that's 0 seconds since the start of the record. And if I double click on this little dot right here on the lower right-hand corner of the box, it will do the calculation for me for all the subsequent columns, or all the subsequent rows. And notice it's not 1, 2, 3, 4, 5. It's 0, 0, 3, 3, 5, 6, 6, 9, 10, 10, 10. So in other words, this particular pterodactyl unit was not running and writing down data on a regular basis, but it was writing down as much as it needed to at every specific time. Let me write a new column here, time, capital T in minutes. Frankly, I understand minutes better than I do seconds. And so this is going to be equal to time capital T in seconds, just divided by 60. And if I double click on the right-hand lower corner there, I get the number of minutes that it's have elapsed. And I'm going to format the cells and just keep 2 digits. So number, 2 digits, okay. That's good. Now let's plot some things. So let me click on the beginning of the time column. And then I'm going to shift click, this is a PC, on the bottom of the time column. And then let me go over here to the altitude column, control click, go back up to the top, shift click. And so now I've chosen time and to the right of it, altitude in feet from the GPS unit. And I'm going to say insert, and I'm going to choose scatter plot. Now this is interesting. What I see here is time horizontally, altitude in feet vertically, but clearly there's some bad data. Some data that came out with a time of minus 1,000. So somewhere in this record, there's some bad data and it's really screwing up my graph. 2 things I could do here. One thing I could do is I could just take a look only at positive time. Another possibility is I could go looking for that data. It looks like that data was taken around 40,000 feet. It may be in the 40,000 feet range, but it should be pretty easy to identify. And the reason is in this time column, there should be some numbers that are around minus 1,000. It's not a tremendously long data set. So in fact, I bet I can find it. Here we go. I'm just clicking through and watching column H, looking for anything that is grossly out of line. Here we go. I'm 25 minutes in, coming along, 40 minutes in, going faster, 50 minutes in, 60 minutes in, 70, 80. I saw it. Back. Oh, there it is. Those are the data points. Those are the bad ones right there. Okay. So for whatever reason, this unit got confused for about 5 cycles. So I'm just going to erase those points. Delete. Now that those points are gone, let me go back, look at that graph again. And the graph is in much better shape now. Okay, so it shows something that was on the ground and then it went up and then it presumably burst and came back down by parachute and then it was back on the ground again. Here's what I might like to do actually. I might like to shift everything over so that the start time is not when I turned on the unit, but when I started to fly. So that means, let me make one final time column. Here we go. Time, I'm going to call this little t. So little t is the time since turn on as opposed to the times, I'm sorry, the time since launch, as opposed to the time since turn on. And it appears to me that this might be in the vicinity of 30, maybe 40 minutes. So how about I say little t is calculated as capital T minus 35 minutes, okay? So there's one time, and that's a negative 35 number. And then now I have calculated all my little t's. Now here's something that's quite cute with Excel, is if you click on the graph, it'll show you what was graphed, and then if you just drag this over, it will graph against that instead. And in fact, I got pretty close. Notice that now time 0 corresponds to the beginning of the flight. So here's what I'm going to do now. I'm going to right-click on the horizontal axis and say Format Axis, and I'm going to make a few changes to how this looks. First of all, I'm going to have it only show me tick marks every 30 minutes. I'm going to have it show me tick marks starting at minus 30 minutes. I'm going to have it show me tick marks only up to 150 minutes because the flight is over by then. And if I scroll down here to number, I'm going to turn off the fact that it says 00 after each of the minutes. I'm going to make decimal places 0. Okay, I would say that's a much better graph already. Okay. Now, so this flight goes from about, on these units, about 0. I could tweak that a little bit. It's really 34.5 minutes or something like that, but I've got 35 minutes offset until about 130 minutes or so. Let's look at some of the other data. So if that's the GPS altitude, here's the estimated pressure altitude. In other words, the altitude based on the pressure reading. If I go back and forth between the two, notice they're not quite the same, but they're pretty similar, meaning the pressure calculation is doing pretty well. And then there was temperature, and that looks lousy. So I bet that temperature, that thermometer didn't work very well. That looks even worse. So somehow the thermometers on this unit weren't working well. Here's the temperature from another device altogether. This is the temperature built into the pressure sensor. That looks more reasonable. And it says the temperature was about 70 degrees. This is Fahrenheit. And then it went down to about freezing, and then it went up a bit, and then it went down to closer to 0. This is Fahrenheit, yes. Yes, this is Fahrenheit, okay? So it did get cold, but not tremendously cold. Here's pressure. And so this is my recommendation, I guess, is get one graph out there and then just use that one graph to look at the shapes of all the stuff. You'll identify things that are clearly wrong, and you'll also be able to see whether or not, in this case, the pressure went down almost to 0 and popped back up again. If I go over here to accelerometer, I can see that the thing was fairly quiet. And then it suddenly got rather noisy. That corresponds to the burst. And then it was pretty noisy all the way down. And then when it hit the ground, it landed apparently on its side because the 0 for going up and the 0 for, or the steady state for going up and the steady state for going down are not the same value. This is kind of like a tip sensor. Here's another accelerometer in a different axis. Here's a third one. Gyroscope. So again, gyro shows that it was not spinning a lot, and then on the descent it was spinning a lot just because it tends to be much more violent in a way like that. The last thing I want to do is I want to show you how to generate from a graph, from not a graph, but from data of this sort, 3D plot. This is actually pretty cool. So let me do the following. First of all, I'm going to look at latitude here, longitude here, altitude in feet. I actually want an altitude in meters column. So let me insert that right next to the latitude, longitude. I'm going to label this and make this a little bit bigger. There we go. Altitude in meters. And the reason is the website I'm about to use expects numbers in meters. And the altitude in meters is going to be equal to the altitude in feet divided by 3.28. That's just how to get from feet to meters. I looked it up. So 1,100 feet, typical for Minnesota, 344 meters. Double click, that gives me all the altitudes in meters. And then I want to take just latitude, longitude, and altitude. So just these three columns. Control C, copy, open up a blank workbook, and then Control V to paste. And you'll notice it didn't work. The reason it didn't work is the latitude and longitude numbers were actual numbers, but the altitude in meters was a calculated number based on some other columns that aren't here anymore. So Control Z to undo that. And I'm going to go up here to say paste values. So don't paste how it was calculated, just paste the answer. There we have it. And then I'm going to save that. So I'm going to go to my desktop and I'm going to save that as, I'll call this GL182, that's the name of the flight, for GPS visualizer underscore com. That's where I'm headed. I'm headed to a website called gpsvisualizer.com. Okay. Okay, fine. Next, I'm going to open up a web browser and go to GPS visualizer. And I'm going to say that I want to generate a Google Earth KML file. So here we go. Click on Google Earth KML, and it says, where's the data? And I say, choose file, go to my desktop, and there it is. That's the data that I just saved. And I'm only going to make one other change from the default choices. I'm going to say that I want the data to be extruded from the ground by a wall. You'll see what that looks like in a moment. And then I'm ready, create KML file. So when I create the KML file, it will either ask me, it's creating it, and then it will say, do you want to open it or do you want to save it? And usually I want to open it. I clicked on it, but it's actually forcing me to save it. That's all right. So I'm just going to put that on the desktop, save. Now, there it is right up there on my desktop. And if I double click on that, you have to have Google Earth downloaded, of course, free download. Let's see what the data looks like. If it puts you somewhere in Asia, that probably means that you didn't put a minus sign in front of your longitude. But in fact, this is showing me Minnesota. This is good. So this particular thing, I can now sort of fly around it. So this was launched from a town called Janesville. I'm zooming in Janesville. It was launched from a school in Janesville. If I can get close enough to see that launch location. Ah, yes, and that, indeed. So we launched from behind this building. If I grab this, I can actually look around the other side. So we were in this playground and we launched. Okay, that's fine. And then it went up and up and up and up and up. I think this is actually very fun to fly around this thing. Tip it forward so I can see. Oops, I took it the wrong way. There we go. Tip it a little bit more. A little bit more. Tip it a little bit more. Anyway, you can play around with these things a lot. What I'm trying to do is I'm trying to see the peak of the flight still above me. There it is. Peak of the flight is right there. Okay, and so it went up, and then at that point it burst, and then it came down and it landed right here. So let's take a quick look at where it landed. And this particular one was landing in an area that was about half trees and half not trees, and it chose to, oops, land in some trees. Google Earth does ask for your altitude in meters, but it turns out it draws the map slightly low. And so this is landing here. It should be on the surface. And it landed right on the edge of these trees. It didn't quite overfly the trees, so we had to go around the trees. So there you have it. Just a few ideas about taking a look at video data and also taking a look at data that was saved in comma-separated value format and pulled up with Excel. And then you can generate extra columns if necessary for time, or maybe better, write down the time columns when you save the data in the first place. And then take a look at things like latitude, things like longitude, things like pressure sensors, and all the other sensors that are on board. And if necessary, shift the time so that maybe time 0 means the beginning of the flight instead of when you turn on the time.